I think that we're good to go. Enat, can you present our speaker for today?
Okay, with pleasure. Today we're going to hear a talk by Ram Fishman, who is a senior lecturer now in public policy in Tel Aviv University. Ram studied his BSc in mathematics in Tel Aviv University, then his master's in physics in Weizmann Institute. Then he moved to the United States to do a PhD in sustainable development in the School of International and Public Affairs in Columbia University. After his PhD, he did a postdoc fellowship in Harvard. Then he was an assistant professor of economics and international affairs in George Washington University. And then he moved to Tel Aviv. And now he's going to tell us about things that we don't usually hear about, which is are the choices that we make and not what we usually deal with. So the floor is yours. Thank you for coming.
Thanks very much. It's really nice to be speaking to physicists. That I also come originally from the exact sciences. And at that time, I didn't even know there was something called the public policy department. And I wouldn't be surprised if some of you also were not aware of its existence. So I basically made the switch to the dark side after realizing that the social aspect of all these problems is very, very challenging as well, both analytically from a research point of view, from a practical point of view. And so that's in terms of my personal history, but it's nice to be speaking to a physics audience again. I am not going to tell you very much about research because I was asked to just give you a very basic introduction to some of the questions that we're thinking about in the policy and the economics domain when we think about climate change. And I apologize in advance if some of these things might be, already familiar to some of you because they're very, very basic elements. If another time, I'll be happy for another invitation to talk about specific research, but now I was asked to just give a general introduction. So when we think about climate change, different communities of scientists think about it in different ways. Obviously, I think for you guys, it's probably first and foremost a physical phenomena, a very complicated and fascinating physical phenomena. I think for the public, it's mostly perceived as a threat for human society in general. And people have different ideas of how severe that threat is. But for us as social scientists, as policy scientists, and especially as economists, this is something that is more of a societal choice. What to do about climate change, how to deal with it, presents economists with a very difficult social scientific question. And as I'll elaborate in a minute, what should be done about climate change and how to do it turns out to be, as in the same way that it has challenged physics and climate science, it's also been pushing the economics discipline to the limit of what it can do, both theoretically and empirically, and it's changing the whole fields of environmental economics. These fields have been around for a long time, but having to deal with this kind of problem has really changed things a great deal and sparked entirely new fields of research. So I want to just structure the kind of questions that we are thinking about broadly into a question about what we should be doing. So it's really like a normative question, but it's not normative in the sense of like a moral question. We approach this question in economics as a cost-benefit question, as a question about an investment. Should we as human society make an investment in reducing greenhouse gas emissions, mitigating climate change in order to avoid some of the future damages? I know that for many scientists, it appears to be like an obvious question. Of course we should. But it's actually not that simple. And there's a real, very challenging question if we are trying, as in any other investment we make, to calculate whether this is a good investment to make. Maybe there are better investments to make with our money. So I'm going to discuss with you some of the aspects of this question. How can we analytically approach the question of what we should be doing, how much we should be investing in stopping climate change, versus letting things go on as normal, business as usual. And some people still think that we shouldn't do anything about climate change, that it's not the most efficient thing for society to do. Others are focused more on how much adaptation we should be pursuing. Adaptation meaning, letting climate change take its course, not trying to stop it, but trying to find ways of living with it in a way that will minimize its negative impacts. But today I want to focus on, I think, the most crucial and interesting question, which is the mitigation. Should we mitigate climate change, meaning stop it from, it's too late to stop it, but reduce the extent of future change, and to what degree should we do that? So the first question about what we should be doing as a society, a global society. Then a whole other set of questions is about, even if we agree that there's a certain level of mitigation which should be pursued, how do we go about making that happen? Just because something should be done doesn't mean that it will happen. We have to think about how we get there. And that's a whole nother very difficult domain. That's where we get into politics. That's where we get into different types of policy choices. So, we don't have a lot of time. I'm just going to touch on some of these things, elements of these two questions, just so you get some familiarity with what we're dealing with. And by the way, if anybody has questions while I speak, feel free to barge in. I don't know, in economics, the culture is very aggressive, so people just jump in whenever. So I'm used to that, and it's totally fine. So let me start with the should part. What should we do? Normally, when we face a decision about an investment, usually what we do is we calculate, or any action we might be wanting to take. In economics, we think about it as something that carries some costs and also carries some benefits, right? Like, I'm going to the gym today, even though I hate it, because it's a good investment in my future health. That's something I think many of us face. And our life is riddled with these kind of questions, whether in the individual level or at the societal level. And, what are the costs of mitigating? In the case of climate change, the costs and the benefits are very clear. The cost is the cost of transitioning, basically, of fundamentally changing our entire energy system. That carries some costs. Some people think they are very severe. They're changing very quickly, and there are many opinions about the extent of these costs. But there are probably substantial costs to doing so. And many of these costs also involve a large amount of upfront investment. What are the benefits of doing it? Well, the benefits of doing it are going to be the damages that we can avoid by doing it, right? So the damages are really, the benefits of mitigating climate change are the avoidance of all the damages that climate change might carry for our society. And now think about the problem, think about it from the point of view of like an investor. An investor trying to, it's like you're an investor and somebody comes to you with a pitch on why you should invest in their product. So how do you make the pitch to an investor that climate change mitigation is actually a good investment? And good enough, a good investment means it's good enough to be better than other types of investments. Keep in mind that, there are many other types of investments we can make as a society. And whatever investments we make in mitigating climate change are investments that we're not going to make in other things that are also important. We can, and some people have this opinion that, a better use of our money is to, deal with certain diseases, eradicate certain diseases that are still causing a lot of harm to human life, invest in better education. There are many investments we can make, and our job is to decide what is the best one to make. And so in order to know how good of an investment climate change is, we need to make a calculation that compares the costs and the benefits.
Excuse me, can I ask a question?
Definitely.
When you say cost, that means also the quality of life. For example, how can you cost benefit the fact that people have forests to walk in, or have reefs to dive in, or
right? So that's exactly a big part of the difficulty. And you mean the benefits, right? Of the benefits of saving those forests and those reefs. Not everything. So usually when we talk about the cost and benefits, we try to think about them in monetary terms, as in a normal investment. And you're right that one of the big problems is some of these benefits are hard to quantify in monetary terms, because things like forests and reefs are not things that are traded in markets and so have a clear price on them. Usually we believe that the price of something in the market reflects its value to people. In the case of forests and reefs, we can't use that approach, because these things are not traded in the markets. They are not, they're not a product that is traded in the market. So we don't know the price. We don't know how to quantify the value of these things. That is exactly some of the challenges that we are trying to face. And economists have developed all kinds of indirect methods to gauge how much value people place in those kind of things. So that's part of the challenges. And again, I'm going to focus on the questions and the challenges here, not on solutions, because this is a big, still work in progress for the whole community. But this is a good point about as you'll see, there's also going to be very, very high, our estimates suggest a very high monetary costs of climate change. Damages. And quantifying the damages that are not monetized is also a question of ongoing research as well, but we're trying to find indirect ways of doing about it. And usually with the way we do it, we try to, one way to do it is like, how much would it cost us to restore a forest if it was damaged? That can put value of keeping that forest or a reef. Another way is to look at people's behavior. How much effort are people willing to make to visit a reef or a forest? So, that's another approach that's being used. So we're trying to find all these indirect ways of measuring it. One may object to the even idea of putting monetary value on these things, and that's also fine. But the approach taken in economics is to try to quantify everything in monetary terms in order to be able to make a comparison of costs and benefits. Okay, so if we go back to other elements of the problem, if we want to estimate the benefits of mitigating climate change, which means the damages we can avoid by doing so, we need to estimate what these damages are going to be. Now, this is a very, very difficult exercise. The first part of the exercise is you guys are in charge of. You have to tell us what is the climate sensitivity. You have to tell us how our climate's going to change as a function of the amount of greenhouse gas emissions over the next whatever years. You have to tell us how temperature is going to change everywhere in the world. You have to tell us how precipitation patterns are going to change. I know that's already very difficult, but let's say that we've solved that part, and you can tell us, you can give us predictions, and probably they're not precise or certain predictions. They're subject to a lot of uncertainty. But let's say you give us a distribution of possibilities for future climate scenarios like temperature, precipitation, etc., etc. then what we will have to do as economists is to somehow estimate how those changes in the climate are going to affect different aspects of our economics and society, how they are going to estimate our income, how they're going to estimate our health, how they're going to estimate food security, agricultural production, other aspects of civil society like conflict, social stability. We would have to somehow estimate all of these things. And in a minute, I'll go back to saying you how we try and do that. Once we did all that, we also have faced another issue, which has turned out to be a very difficult problem conceptually, is many of these damages are not happening next year or in 2 years. They're going to happen, in 50, 60, 70, 100 years, 200 years. And how to compare the value of things that are going to happen in 200 years to costs which we are going to bear in the next 10, 20, 30 years turns out to be a very difficult problem. So I'll touch on that also if we have time, okay? And finally, there's the issue of uncertainty. We're not going to have certain answers to any of these elements of the calculation. We're going to have a very uncertain result, a distribution of possibilities with fat tails, and our normal way of incorporating uncertainty and risk into investment decisions are really going to be pushed to the limit by this kind of uncertainty, and we're still struggling on figuring out how to deal with that. Okay, so these are some of the big questions we're going to have to deal with as we try to do the cost-benefit calculation for climate change mitigation. And I just want to emphasize, this is not just about whether to do nothing or something. This is about how much mitigation and when to pursue it. And even though I know that for many scientists, again, it's a given, of course, we should mitigate to the fullest possible extent. It's actually not an obvious question for many economists. Any questions so far? I hope the general framework is sort of understandable. Okay, I'll take silence as agreement. So let's talk a little bit about how we try to estimate what the damages of temperature increases are going to be in the future. So how do we do that? How would we go about figuring out what's going to happen to our economy, to our society, in a world in which the average temperature is 3 degrees higher than it is today? How are we going to do that? There are two basic approaches. One is to try to simulate that. If we have some model of the economy of society, in agriculture, we often have crop models. These are physiologically inspired models that simulate the growth of a plant in response to all kinds of pressures, all kinds of biotic, abiotic circumstances. It's a model. You plug in the environmental variables, they predict the yield of the crop. So even in agriculture, these models are very imperfect, and we have nothing like that when we want to speak about society. Economics is a very, very undeveloped science compared to the natural sciences, to the exact sciences. We don't have a model of society or the economy to which we can just plug in some external forcings and predict what's going to happen. We're nowhere there. So trying to simulate exactly how every change in temperature is going to affect every person's decision-making, health, how that is going to affect economic productivity, the markets, the politics, is just hopeless. And that's why most of the research on this is empirical. It doesn't try to understand why all these things happen, because they're so complicated, but it just tries to look at historical data to empirically estimate what happens when the temperature is high or low, above average, below average. What happens when the precipitation is high or low? What happens when you compare places that are cold to places that are hotter? What do we see in the data to tell us empirically about what the relationship is, the correlation between climatic forcings and societal outcomes are? This can give us an empirical result, basically a regression result, but it may not tell us about the mechanisms, but it's going to tell us a bottom line. And that is the approach mostly used by economists to try and predict what will happen with climate change. Let me give you an example. I'm not going to go into all these details, but here is a simple graph showing us basically GDP per capita. That's basically the average income per capita in a country, plotted against the average temperature in that country. Okay, this is just observational graph plotting GDP per capita, the income, which is an indicator of economic development, against temperature. Now, you know that income has huge amount of variation across countries in the world, between like the advanced industrial economies of Europe and North America and the poorest countries in the world in Sub-Saharan Africa and South Asia. I mean, we're talking about sometimes a factor of two orders of magnitude differences.
Well, but here, Jim, where would it put the UAE, which is the hottest country in the world, 50 degrees in summer?
Right, the UAE is so first of all, just if we look at the average slope, we see a negative relationship, right? Higher temperature generally means poorer countries. Of course, it's just a correlation and it's not completely deterministic. There are many outliers like the UAE, which is very hot and very rich. And we know why that is an outlier.
Then there is Singapore also.
Exactly. Singapore is another good exception. And we also have good theories of why Singapore is an outlier. But if you look at the overall correlation, it's very clear that there is a correlation, a statistically significant association between GDP per capita and temperature. Obviously, temperature is not the only thing affecting GDP per capita. There are many other factors which are more important probably, but there is a negative correlation. And this negative correlation holds not only across countries, but also between countries. Within countries, if you compare colder and hotter areas, on average, the hotter areas are poorer. Now, this is very problematic, because a very naive extrapolation of this would suggest that as climate changes and warms, countries are going to move along this curve, right? As the temperature moves, then their GDP per capita is going to decline. And that means that our GDP per capita is going to suffer a lot because of climate change. But this is a very naive and problematic extrapolation because we don't know whether this is a causal relationship. Just because there is a correlation doesn't mean that it's the high temperature cause more poverty or lower economic productivity. And we can't isolate all the other potential factors that influence this relationship. And that's why what mostly we do in economics is something else. We look at instead of comparing different places and cross-sectionally, we look at temporal variation. So we look at the same country or location over time. We look at the time series, and we look at many time series together. And we analyze whether temporal fluctuations in temperature are associated with changes in societal outcomes. And we have techniques to isolate only the effects of unexpected random fluctuations in the weather from year to year, climatic variability, from trends, from seasonal effects, etc. And by isolating only the random fluctuations in weather from year to year, we are able to extract correlations which can be interpreted causally. Okay? That is a great advantage of this approach because these are causal associations, so we can more safely extrapolate them to tell us something about what climate change will do in the future. But they have a major drawback. And the major drawback is they tell us what happens when there is a high frequency change in the climate, right? They tell us what happens to a country when it experiences one hot year. And experiencing one hot year is different from a permanent shift in temperature. And that is a challenge we have whatever we learn from looking at the time series of annual changes may not predict what will happen if the change is permanent. If I see that a country, when the temperature goes up by 1 degree, loses 3% of its GDP per capita in that year, doesn't mean that when the temperature permanently changes by 1 degree, then also income per capita is going to permanently change by 3%, right? And we'll touch upon that later, but first let me show you some of the results. And then there's been an explosion in the last 10, 20 years in very good empirical research, utilizing more and more fine data on the association between temporal fluctuations and output. It started in agriculture. And in agriculture, the finding was because people thought, obviously, that's the one sector of the economy that's most sensitive to climate. So it started there, and there people found a lot of interesting results, including very nonlinear effects, where things are kind of stable, but as soon as temperature crosses a certain threshold, there is a very rapid decline in crop yields, for example. These are all based on data, like county level data in the US of yields and temperature. Many other studies have been done in many other parts of the world, globally. Many of these studies are published in Nature and Science and PNAS, etc. And there were indications of very severe impacts historically of hot temperatures. Maybe what is even more interesting and less and more surprising is that we are now realizing the effects are not limited only to agriculture. They're actually, if you look at the entire economy, it's not just crops that are suffering, not just agricultural sectors, but there is actually, it turns out there is actually a very strong effect on economic growth. On years in which GDP and temperatures are higher than expected, the income of that country, GDP per capita, declines. And we see it as a nonlinear relationship, as you can see in these graphs. And it's not just for agriculture, but even for non-agriculture GDP, and it affects both poor and rich countries. And that is based on country level data, looking back at like 50 years of data on annual GDP, temperature, precipitation, etc. If you take these and then you extrapolate into the future, then you start to see some very serious effects of, depending on the scenario, but we're starting to look at, some of these indications are starting to show things like, for 3-4 degrees, we might be looking at 20-30% reduction in GDP per capita. That is an economic disaster. Keep in mind that normally the world economy has been growing at around 1 to 2% per year for a long time. Some countries grow much faster, some countries grow much slower. When we have a recession, we're talking about that growth slowing down. When we have a pandemic like COVID-19, a global economic crisis, we are talking about some contraction, but it's expected to only last 2-3 years. The societal implications of such a drastic reduction in GDP per capita are enormous. So these estimates are very alarming. Here is a graph of how it's going to change the global distribution of income. Some countries may benefit, but a lot of the poorer countries, which are already hot, are going to suffer enormous damages to their economic productivity. And the thing about GDP per capita, you may think GDP per capita is just about money. It's not about quality of life. But almost every indicator of well-being, education, energy access, health, subjective reports of happiness are strongly correlated with the economic condition of the society. So these kind of studies are very worrisome in terms of what they predict.
What is shown here, actually?
Yeah, so I'm going very fast because I want to get a lot done in our brief time. How much time do I have left, by the way?
Maybe 15 minutes.
Okay. So let me just very quickly, and I can send you the paper. This is a simulation based on the regressions that examine the relation between GDP per capita and temperature, trying to extrapolate what will happen to the GDP of different countries in the future. So for example, if we look at the left graph, it depends on the climate scenario you're examining. The gray bars are the business as usual. What would happen without the effects of climate change? If we could solve climate change today, this is the economic trajectory of the world, every line representing one country. And the y-axis is GDP per capita. The red lines show you how that would change if you take into account how warming is going to affect the growth of these countries. So it's not just the average reduction in GDP per capita, but it's how it's distributed across countries. Okay, so you see that for some of the poorest countries, they're going to do much worse. And that is partially because they are warmer to begin with. Okay. You get similar results when you look at not just GDP per capita, because you can say, okay, I don't care about the economy, I care about social stability. But if you look at whatever data we have, historically, long-term, and currently, the evidence that's been coming in from a large number of studies is showing a strong correlation between climatic variability and the collapse or social instability, civil conflict, intergroup conflict of any kind between countries, between groups, between individuals, and the collapse, including major historical events like collapse of many societies. These things are quite well correlated in many different contexts with climatic variability, most of which is more modest than the kind of that we are expected to experience here. So a lot of studies looking at all kinds of things, civil conflict, crime. I've also done studies about crime in India and how it relates to temperature. You find very strong effects, very strong statistical significant effects between heat, drought, and crime and conflict in many parts of the world. So that also is suggesting to us how sensitive our society is to temperature fluctuation. And that is something we were not really aware of until we started to look at the climate change question and starting to look at this historical data. We are starting to realize the myriad and complex ways in which changes in the climatic variability really affect our societies, how vulnerable we are to these effects. Now, one major objection to extrapolating these kind of studies to predict the future is, again, what I mentioned before, the difference between 1 year of bad weather and a permanent shift in bad weather. On the one hand, you might expect that a permanent shift in the weather might, be more damaging than just 1 year, right? So if I experience 1 year of drought, maybe something bad happens in that year, but I recover maybe, maybe I use water from some reservoir, etc. But if I were to experience a permanent drought, same change, but permanently because it's a change in the climate and not just 1 year, then you might expect the effects to be worse than what I would extrapolate on the basis of 1 year of drought, right? Because water will run out from my reservoirs, etc., and my capacity to deal with it will just erode and erode. On the other hand, you might expect that we are going to find ways to adapt. Maybe 1 year of hot weather is not worth doing too much about because we know it's only 1 year and it's going to go back to normal next year. But if the change were permanent, then one theory is that individuals, societies, countries will make investments that will allow them to adapt to these changes. For example, if we see that the change in the temperature is permanent, maybe we'll just invest in more air conditioning capacity. And that is going to reduce the negative impacts on our society. And so these predictions based on these extrapolations are actually too pessimistic. And that is exactly where the challenge is for this literature right now, trying to figure out empirically to what extent adaptation is actually pursued in response to climate variability and to what extent it can change these extrapolations. This is a more difficult exercise empirically because we don't have so much variation in long-term environmental changes in history to look at in order to do a statistical analysis. So we're trying to find all kinds of ways to get around that. But that's one of the big question marks around the attempt to estimate future damages. Then there's the issue of the future, because many of these, so here we are talking about an investment that's the fruit of this investment are going to be avoiding damages that are going to occur 50 or 100 or 150 years in the future. And this puts our normal framework of evaluating future events, really challenges this framework, really pushes us to the limit. What do we usually do? You know, it's very simple. We usually take the interest rate, R, and, you know, if something to value, when you take a loan in the bank, the returns from the loan are calculated based on the interest rate, right? If the interest rate is 3% per year, then you'll take 1.03, take that, and you want to get the loan back in 5 years, you'll take that to the power of 5, and that will tell you to what extent, how much you are expected to get per dollar you're giving today, right? So we use interest rates to tell us about future, how to compare the future and the present. But when we are talking about 100 years, this framework becomes a little bit ridiculous, because any reasonable interest rate that you will choose, if you exponentiate that with 100 years, you're going to get a very small number. And it doesn't matter if you take 3% or 4% or 5%, when you exponentiate that to the power of 100 years from now, it's basically going to tell you that whatever happens in 100 years is almost insignificant, right? It's not really worth putting in any large amount of money in right now in order to get a similar amount of money in 100 years from now, because we are going to discount it very heavily. So that has really pushed economists to reconsider this whole approach and think about why at all are we valuing the future less than the present. And it's created a whole body of theoretical investigation into how the future should be valued in cost-benefit analysis, especially the distant future, in relation to the present. What is the correct way to do that to factor that in? And again, a problem which has not been fully resolved yet, still a matter of debate. I hope I'm not going too fast and lost all of you. I just want to give you a taste of all the big questions we are thinking about. And then there's a lot of uncertainty. So if we try to calculate what is the cost of climate change, it's called the social cost of climate change. It means really trying to do all this and calculate every ton of greenhouse gas emissions released into the atmosphere today. What is the economic value of that? Or the value of the economic damages that will create for us from today and until 200 years from now. We have to, again, calculate how it's going to change the temperature and the precipitation in every year, how that's going to affect GDP and conflict and health, and put money value on that. When you do all that work, people come up with these estimates. And there's a very wide spread of estimates because all these calculations are riddled with a lot of uncertainty, which also, by the way, incorporate the physical uncertainty about the value of the climate sensitivity. How much is the temperature going to change because of every additional ton of emission? So we have a wide range of values, and how to deal with this uncertainty in decision-making is also very difficult. Now, in practice, what has been happening is that even if originally the idea was economists were thinking about figuring out trying to calculate somehow through this exercise, what is the optimal value of mitigation we should be pursuing? The optimal value means the amount of mitigation until which mitigating more is still profitable, but above which mitigating more than that is just not going to justify, is going to cost more than the damages that we will save. But what really happened in practice while economists were debating all of that is that the global dialogue on climate change got focused on what we need to do to reach a certain level of warming. You know, sometimes it's 2%, 1.5%. These are and I'm sure you're familiar with these numbers, these are the thresholds or the targets around which the international community has basically started to focus the discussion. And that has not come from an economic calculation. That has come, from some pretty rough And it's not clear exactly where these numbers come from, but there is some assessment that that is like still the safe value of warming that will avoid catastrophic feedback loops or irreversible changes that are very catastrophic. The actual evidence basis for that, I think, is not very solid, but that has become really like the defining target for international policy. And I think largely it's because economists have failed to come up with a more reliable answer to the puzzle I just presented you around what is the actual optimal value. And of course, there's a whole discussion of the climate budget. How are we going to not exceed that threshold? How much emissions can still be tolerated in order to not exceed that threshold of 1.5 or 2 degrees above pre-industrial levels? And there's a whole discussion how quickly to do that. Should we start today? How fast should we start today? Should we wait, etc.? So this was all about benefits. We can also talk about the cost. How much is it going to cost to avoid climate change, meaning to decarbonize our economy, and to what extent? And here too, things are changing very rapidly. A few years ago, there was discussion of like maybe 1% of GDP, which is sizable but manageable. Today, some people think the costs are actually negative, meaning that it's actually becoming cheaper to generate power from renewables in some contexts. I think that's still debated, it's not clear. And especially if you also take into account the health benefits that are not climate change related, like air pollution related. If you decarbonize the economy and the transport sector, you're not only mitigating climate change, there are more benefits. There are air pollution benefits, and air pollution carries enormous economic damages. It kills a lot of people in the world still today. And so when you factor all these things in, some people believe the costs are negative, meaning even putting climate change aside, that's something worth doing. So that's debatable. And also, even if that's true, it still entails a lot of upfront investment. Huge amounts of, hundreds of billions of dollars of investments are needed. And it's not clear exactly where to get that, how to get that finance happening. So I just wanted to mention that. And finally, I want to mention a few words about even if we decide that something is optimal from a societal point of view to pursue, the question is also how do we do it? Not just what should be done, but how to achieve that. And here we get into this issue about climate change being the biggest market failure in history. What does that mean when we say market failure? So basically, even if usually economists rely on markets to reach the most optimal and efficient outcomes for society, at least in terms of income. But often markets will fail in doing that. And climate change is a primary example of where markets are not going to be able to do it for us. And when I say markets, I mean just the free decisions of economic agents to decide about what they produce, how much they produce, what to buy, what to sell. The market forces which have generated the enormous economic growth of the last century. When it comes to climate, markets cannot be expected to deliver because the climate is a public good, what we call a public good. So everybody knows the prisoner's dilemma in game theory. A very simple extension of that model explains why something like the climate, in which everybody enjoys, is not going to be protected by individual actions of self-interested people, right? No, but because every contribution I make to preserving the climate by using less energy, for example, is going to be enjoyed by everybody. I cannot capture all the benefits. And theory predicts that people with some degree of self-interest who are trying to maximize their own welfare will never supply enough of climate protection. And therefore, that means that, Even the most neoclassical, neoliberal economists will have to acknowledge theoretically that you cannot rely on free markets to solve the climate issue. Therefore, we need policy, because policy, the reason we have governments is exactly to pursue the kind of collective action that individuals will not supply on their own. So what kind of policy can help solve something that the market and individual source cannot do? First of all, we might feel that even though theory predicts this kind of behavior, in practice, more and more individual voluntary action from all of us can solve the problem. Maybe all the more awareness will just lead people to use less electricity, to consume less meat, which is a very greenhouse gas intensive product, and take other actions to reduce their individual footprints and emissions. And I am often surprised by how much emphasis people place on that. A lot of people seem to think that the key to mitigating climate change is for all of us individually to take actions, to use less electricity, to buy more energy efficient products, to buy electric cars, to install solar panels. And in my mind, theoretically, theoretically, you could imagine where a large contribution can be made that way, but in practical terms, I think there's basically zero hope that just individual action is going to deliver what we need. I mean, the extent of the reduction in emission that we need is so enormous. We really need to completely decarbonize the economy. And to expect people to solve that individually is about as naive as expecting in a response to a marching army heading towards our country, for some volunteers to pick up some stones and sticks and go in and meet that army and confront that army. That's completely naive. What we need to do to address climate change with any hope of really mitigating has to happen through a political action by governments at the policy level. What does that mean? That can involve regulation. For example, governments can dictate that certain industries or individuals cannot emit more than this amount of greenhouse gases, or need to use this kind of energy source, etc. Really aggressively intervene and force certain behavior and choices on individuals and industries. For example, forbid meat consumption. But usually economists much prefer and think it's much more efficient to governments to just create the incentives which will then allow the market to do its magic. So it's not about confronting the free market, but about giving it a nudge in the right direction. How do you do that? Well, the principal way of doing it is a tax. From an economic theory point of view, the most efficient way to get people to reduce their greenhouse gas consumption is to put a tax on greenhouse gas emission. So every industry, every agent that is responsible for the release of 1 ton of greenhouse gases will have to pay a certain price for that ton, which will reflect the damages associated with that emission. Economic theory predicts that will lead to the most efficient way of addressing climate change. People will then adjust their actions and decisions to be optimal in order to reduce emissions at the lowest cost. Because those industries for which it's cheapest to reduce emissions will do that first. So from the aggregate point of view, that is the most efficient way of addressing the problem. The problem is that taxes are unpopular. Einat, I'm out of time.
No, I just want to say, how about stopping subsidies for carbon-rich fossil fuels? That would be better than is just stop giving them the billions of dollars.
Absolutely, and that's a no-brainer, right? So I'm going to get to so far I've been like naively ignoring the politics of this and just focusing the economics. From an economics point of view, those subsidies are distortive, they're unjustified, and they should be removed, and then carbon should actually be taxed. Here, the problem is mostly that we run into a problem of politics. Governments don't like taxing people. And especially in the US, the word tax is like evil. And obviously, we all know that the US is the one country which is, from a global point of view, both politically in terms of emission, probably the worst climate rogue in the world. Hopefully that will change a little bit now. But those are the kind of policies that economists would normally promote for efficiently dealing with a problem like this, taxes. And by the way, taxes don't have to hurt individuals. One of the proposals is tax everybody for their emissions, but then take all the revenue you get from that and distribute that evenly in the population. So in that way, you're not hurting anybody. You're not placing on the aggregate any economic burden on firms, but you're still creating the right incentive. There's also this idea of a cap and trade regime, which is very similar in what it can achieve. It basically says the government will say, okay, we are reducing our emissions to a certain amount every year, and we have a pathway. And then we're gonna issue permits for greenhouse gas emissions totaling that amount, but we're going to let firms trade within them. We're going to create a market for these permits. That's something that's happening in Europe. It's happening in some parts of the US. It's more politically acceptable than taxes, but still it hasn't been adopted very, very widely, and it has been functioning so-so. The results are kind of mixed. But another thing that government can do, in addition to incentivizing less emissions, is to invest a lot in R&D. We need massive investments in R&D for energy efficiency, for lowering the cost of renewables. And so far, the extent of R&D globally has not been as high as it probably should. R&D, good technological progress can probably be very, very effective in promoting decarbonization. And then, of course, the other thing government needs to do is to make massive investments in infrastructure, in renewable energy infrastructure, for example. Again, this is something where just the market is probably not going to do it by itself, and where governments are needed. And we know that many governments are really lagging behind in following up, first of all, on their commitments, individual country commitments to achieving the 1.5 or 2 degree goals. And this is also where, if we go back to the role of individual actions, I think where individual action can be much more effective than trying to reduce individual emissions is to trigger the necessary political change. It's governments who are going to be able to mitigate climate change, not individuals. But governments need to be pushed to do so through individual political and activist action. And this is where I think we can make, as individuals, much more of a contribution than by trying to reduce our own emission. We can push our governments to make sure not that whatever electricity we get in our homes comes from renewable sources. That is up to governments to do. No individual is going to build their own power station, of course, unless it's a solar rooftop system, but those by themselves are not going to be enough to really get us to where we need to go. And then, just to throw one more complicated bit of one more issue into this mix is the distributional issue. So even if we agree that from a global point of view, mitigation is a good investment, and we should pursue it, how to divide that between the different countries of the world is a complicated economic, justice, and political issue. Unfortunately, we have a global issue, but we don't have global governance. We don't have a global governance mechanism that can force governments, countries to follow certain policies or emission targets. We have an attempt to reach international treaties on everybody doing their share. But those treaties until now, first of all, we only recently have been able to reach the first treaty, the Paris Accord, of course. The commitments in the Paris Accord are, first of all, insufficient to meet the 1.5 or the 2 degree targets. Governments are not actually even on track to realizing the commitments they have made, and they're not pushing those commitments sufficient. They were also expected to be, making more ambitious commitments with time. That's not happening rapidly enough. On the other hand, there has very slow movement in this international diplomatic process. There is movement. It might be too slow. Time will tell whether it was too slow. But this is the arena in which we live. In this kind of arena, obviously, this is a problem that all countries need to take part in the effort to solve. And I think some of the breakthrough actions that have happened in international climate agreement have been like the agreement between China and the US that has basically triggered the process that led to the Paris Accord. When a country like the US basically pulls out of the international effort, that is extremely damaging. Luckily, it hasn't derailed the Trump administration's retreat from the Paris Accord, and all domestic environmental climate policy has not derailed the international agreement, but it's definitely set us back in terms of the timeline for achieving those goals. Hopefully now with the new Biden administration, we're going to see more decisive action on climate change there, but that very much depends on what happens, as we know, in the US Senate, the ability of the administration to pursue aggressive climate action. Being in the middle of an economic crisis related to COVID is not helpful at all. So those who rejoiced about the temporary reduction in emissions resulting from the economic slowdown in the wake of the COVID pandemic, I think that was very much misplaced. I don't think any environmentalist should have been happy about the short-term environmental consequences of the COVID pandemic. True, in the short term, there was a reduction in emission because economic activity slowed down. Whenever there's an economic recession, greenhouse gas emissions slow down, but they always pick up very quickly when the recession is over, and they compensate for whatever they're missed. So this having like lower emissions for 3-4 years is negligible in the big picture of the climate budget. What is much more important and very worrisome is that during an economic crisis, there's much less political willingness to make investments in the environment, including in climate change. There's just less money in the economy to make any kind of investments, including in renewable energy infrastructure. And political crisis usually helps populists to power, and populists don't really care about international cooperation, about long-term investments. And so I think that the COVID pandemic and the economic slowdown that it triggered are terrible news for the climate agenda. On the other hand, it can also be utilized, since governments are forced to intervene in the economy. It's an opportunity to intervene in a way that will fundamentally change the priorities of the economy. And if you heard about like the Green New Deal in Europe or proposed in the US, these are basically programs which try to combine economic recovery, government investment in economic recovery, with investments in renewable infrastructure. Take the opportunity to intervene in that direction.
We need to end.
Okay, I'll just end with one sentence. One of the biggest issues in this international discussion is the distribution between the developed countries, the rich countries, and the low-income countries. The low-income countries, Asia, Latin America, Africa, most of the future growth in energy use and emissions are going to come from those countries because they are growing economically, finally coming out of poverty. So the burden, the rich world is telling these countries, you have to grow without greenhouse gas emissions. And those countries our reaction is, that's not fair. The rich, you have grown through creating all this pollution. This is all your responsibility. We cannot be expected now to give up on cheap fuels as a way of coming out of poverty. And this is where a lot of the negotiation internationally are taking place, how to distribute the burden of these costs between the rich and the poor. So I'll end here. I'm sorry, I know I covered too much in the short talk, but I just wanted to give you some of the main kind of questions that we are dealing with in this kind of research. Thank you.
Thank you, Ram. This was brilliant. I really like this talk. Einat, do you want to handle the questions? You up for that? I'm not sure that we have any more time left, but maybe one or two questions.
Can I ask? Uri?
Yeah, go ahead.
My question, it's actually more of a remark and then a question. I think that climate change is only part of a much larger problem, and this is the fact that we envision all the time ever-growing economy. What about reaching a steady state, I mean zero growth economy? Because if we consume all the resources of the earth, in order, for instance, to accommodate climate change, we have to increase mining of many metals. Some of them are highly toxic. And there is a very strong effect of this on the environment. So we somehow stop population growth and increase in standard of living. And this, of course, implies that we have to distribute more evenly the wealth, take from the rich and give to the poor.
Yeah, I think that's a very important question. Why do we need to have continued economic growth given the environmental damage that it creates? Why do we need to have, maybe it's not worth going to the next model of phones and whatever else, and the cars and everything else. Maybe whatever we have now is good enough. And maybe you should even reduce some of our consumption, but certainly not keep growing it, given the damages that the deep damages that it's doing to our environment. So I'm very sympathetic to this view, but I think that we also have to be aware of some of the consequences of stopping economic growth. Economic growth, and in general, this idea that GDP per capita is a good metric of human progress. It's not a good metric of human progress, but we don't have a better one, unfortunately, that's very useful. So part of the problem is that, even if we feel that having a better car and a better phone and all these plastic toys and all these things are not that important, the real deep challenge about that is that the things that are important in life, like life expectancy, health, the poor, letting the poor have the basic necessities of life, like food security, education, those are things which all of us would consider to be important. And the way in which the world has been able to provide these important things to more and more of the global population over the last 100, 200 years has been through this imperfect thing we call economic growth. We don't have a way, let me put it like a little bit in a funny way, that we haven't found any system, any model of economic organization that gives us the important things in life, like better health, food security, and so forth, education, without also giving us the consumption of things that are not that important and create all these environmental damages. We don't have any proven economic system that can deliver one without the other. And so if today we say, let's stop economic growth somehow, we first have to realize that one of the things that are going to happen is the poor are going to suffer the most. When there is economic recession, when there's no growth, growth is not just about the rich getting more and more useless consumption. It's also about poor people suffering in things that are much more important. People losing their jobs, a lot of human suffering. And so just stopping economic growth is going to lead to a lot of human suffering, especially for the poor. And we have to be aware of that when we discuss the idea of zero growth. We don't have a formula of separating the good stuff from the useless stuff, unfortunately. And that's a huge challenge for our economic system. Now, I just want to say, I totally believe that even if the economic system we have right now is highly imperfect, and the problem is we don't have a better option right now, and we can't wait for a better option to come. And the good news is, within the framework of the neoclassical market economy, the capitalist market economy, climate change can be solved totally. It's not really a problem with the economy. I see it more as a political problem now. Just sending the right signals by the government can lead the market to solve this problem. And making the investment in the infrastructure, incentivizing low carbon activity is going to work. The problem is not the economic system now, the problem is the political system. Our politicians and governments not doing things that are going to work. It's just political will. Nothing else is in our way right now, in my opinion.
I also have a question. With respect to the first part of the lecture, you try to predict the changes in the GDP. And I wonder if it will be more effective to try to predict like risk assessment for some negative events like big wars or catastrophic events, rather than predict changes in GDP.
Yes, absolutely. So there is a lot of studies that are doing that. So it's not, instead of just predicting GDP growth, there are many studies using similar methodologies to predict the occurrence of civil conflict, of other societal outcomes, health, many kinds of things, crime. So there is a literature that does exactly that. I haven't covered everything, but you're right. It's there, and it's also finding similar results.
Do you have one last question, or?
Yes, I have a question about the politics. It's the problem is, for example, in Europe, the new Green Deal. So on the one hand, they want to incentivize green energy and move away from fossil fuel. On the other hand, they're continuing to subsidize fossil fuels. So in Israel the same. And the U.S. the same. So with these huge subsidies that shadow by far the subsidies given to green energy, how do we even have a chance to stop global change? How can we stop these subsidies?
Yeah, so I think obviously these subsidies need to be stopped. Just stopping these subsidies is not going to be nearly enough of an effort. But it's obviously something that needs to happen. By the way, these subsidies they're substantial, but they're not as huge as people sometimes think. But of course, they're ridiculous to have. Why do we have these subsidies? There are two reasons. The cynical answer, these are just the corruption of the political system and how it's being held captive by the interests of big oil, big coal, etc., big gas. Those industries are very powerful. They have created a lot of political influence over a long amount of time, and in many countries they are able to have a very strong impact on policy. But also, in some cases, these subsidies were put in place in order to make energy access affordable to the poorest household. So I think a main message from me to you as physical scientists, and something I myself did not realize until I was exposed to the economics of it and the welfare of all of this, is that what makes this question of climate change, sustainable development really hard is how to balance environmental benefits and helping the poorest people in the world come out of poverty and have access to basic services. From an environmental perspective, obviously any kind of energy subsidy is horrible. Any kind of fossil fuel-based energy subsidy is very damaging. But we have to keep in mind that often they go to help the world's poorest people to make ends meet. And we have to be aware of that side of the coin in order to not be very one-sided and superficial in our thinking about that. There are other ways to help these poor. They can also be given renewable subsidies. All I'm trying to say is that sometimes what we see as a pure evil from the environmental side is a good thing from the point of view of the poor, and we cannot neglect their condition when we think about these global problems. So, and that's something I was completely not aware of until I started studying economic development. For billions of people in the world, this is, you know, a lifeline to affordable energy. So I'm not saying it justifies it, I'm just saying it's something we should be keeping in mind when thinking about, so we don't oversimplify the policy space and the policy dilemmas around these things. I just want to say in closing that it's really fun to talk to scientists like you, and I think we should find ways as communities to have more interaction between us. Some of the best research that I described to you comes from people working between social scientists and climate scientists or other physical scientists to try and you know, combine data from two sides and methodologies to improve our understanding of the interaction between the human side and the natural side. And I think in Israel, we don't do it enough, and maybe we should find ways of doing more of it. So it was really nice talking to you, and thanks for the opportunity. And please keep in touch.
Yeah, I think I very much agree with your last comment. I think it's we should do it more often.
And I would say that especially what's missing in our field is more people coming with a background in quantitative, analytical, strong skills and applying them to problems that also include the human side. And that was the trajectory I did. And often in Israel, the skill set is also too much. This kind of skill that you guys have and teach are very important to bring into the social sciences. And that's been happening, and it would be great to see more of it.
Awesome. Yeah, no, I totally agree. All right, so I think that we're going to adjourn. And I'd like to thank you again, Ram, for a very interesting and thought-provoking talk. And we'll meet again next week. We have another seminar. Right. Thank you. Cheers. I'm going to end the meeting. Right. Bye, everybody.